All right, I hope you have a happy Halloween this weekend, and this lesson is for our asynchronous day. You are to watch this video and fill out these notes on the next page, and then do the 6 problems that are on the second page. So here we go. All right, so you have learned 3 different methods for solving quadratic equations. If you know that, you have learned how to factor. So you've learned to solve by this F1 factoring. You have learned to solve them by taking square roots. So we're going to abbreviate this with F, SR, and you've also learned recently the quadratic formula. And I have the good old quadratic formula right here for us in case we need it. Okay, so there's these 3 ways to solve quadratic equations, and the hardest thing sometimes is deciding, like, what method do I use? All right, so I would recommend to always put my equation in standard form unless I'm going to be using square roots, and then that's not really necessary. So remember when we did square roots, when you have a problem that has a little x in it like this or like this, we can't use square roots on that because I need something only with x squareds and constants, or regular numbers. Okay, so let's look around at these problems. That's the easiest one to pick out of the bunch. So if I look at, obviously A and B are no good. C and D, well, let's see, letter D, that 13x ruins it. But look at letter C. Letter C has 27x squared and 2x squared. I can put those together, and then the rest of the things are just numbers. So that is going to be square roots. All right, that's my choice. So I'm going to try to get the x squareds on one side and the numbers on the other. So I'm going to take away 2x squared from both sides. So that gets me 25x squared plus 4 equals 104. Now remember, you're supposed to be taking notes on this, copying these examples down. All right, and then I'm going to go ahead and take away 4 from both sides. So I get 25x squared equals 100. I'm going to go ahead and divide by 25. So now I have my x squared alone. And actually 100 divides by 25 and makes 4. So I got x squared equals 4. All right, and then I come through and I just do the square root of both sides. And I remember that I am going to put a plus or minus on my answer, and the square root of 4 is 2. So that's done, nice and pretty. All right, so D wasn't square roots, so let's look around at the rest of them. F is kind of ruined by this guy right here because I know I can't do square roots with that. But look at letter E. Letter E has that parentheses. If you don't want to use square roots, the only way to solve this would be to go ahead and square that out. So don't write this down, but you would have to put x plus 5 2 times. You'd have to FOIL it out. It'd be a big mess. And then you'd have to, after that, you'd have to go and do factoring or the quadratic formula. All right, so that's a lot of work. So if I would just recognize that if I move this 4 to the other side, I would have x plus 5 squared equals 18. And I can take the square root right now. So I do my square root. So x plus 5 pops out like we talked about last time. And I put plus or minus radical 18 because I don't know the square root of 18. I will reduce it later, but let's just take care of this 5 first. Remember, I'm going to take away 5 from both sides, so a really quick thing to think about is just you're going to pop that 5 over in front of that plus or minus. So x equals, that 5 turns into negative 5 plus or minus radical 18. Now, so my choice was square roots because I had that parentheses squared there. So let's look at 18. 18 is, how about 9 times 2? And then 3 times 3. So look, I got double 3's. So 18 is really 3 radical 2. So all I'm going to do to finish off is put negative 5 plus or minus 3 radical 2. And there will be my solution. All right. So the rest of these, once the square roots are gone, then I can do factoring or the quadratic formula. All right. So we need to get all these things into standard form. So to move this letter A in standard form, I'm going to pop that negative 10 to the other side. So it becomes x squared plus 7x plus 10 equals 0. And let's look at letter B also. I'm going to pop that 3 over there. So it becomes 7x squared plus x minus 3 equals 0. So those are pretty easy to get in standard form. All right. So the next thing we're going to do is this. you see this little piece of the quadratic formula up here, b squared minus 4ac. That's called the discriminant. All right, there's a t on the end. A discriminant. The discriminant tells you whether or not you should try factoring. So let's figure that out. What is b squared minus 4ac? So in letter A, my b value is 7. So 7 squared is 49. Minus 4 times a is 1 in this problem, and c is 10. All right, so I put that in my calculator. Let's see. 49 minus 1 times, 4 times 1 times 10. And I get 9. So this discriminant is equal to 9. So that means there would be a 9 underneath my radical. I know the square root of 9. So that also means then that I could factor this, because if my number inside the radical is going to be pretty, if my discriminant is a nice, easy, perfect square that I know the square root of, I should be able to factor this problem. All right, and if you don't like factoring, then you could continue on with the quadratic formula and you're halfway done. So, but on this one, I think you could probably tell I could factor it right away, because 5 and 2 make 10 and also make 7. So I'll go ahead and do x plus 5 and x plus 2 to factor that out. And then when I solve each one, I get x equals negative 5. And from this guy, x plus 2 equals 0, so I get x equals negative 2. I think you're pretty good at that. All right, so let's go ahead and do letter B. So let's do my choice was factoring. That was my choice, square root, factoring, and square roots here. Okay, all right, so this one, let's go ahead and do my discriminant. My discriminant, b squared, so this b value is 1. So 1 squared is 1, minus 4, a is 7, and c is negative 3. So if I figure that out, 1 minus 4 times 7 times negative 3. Oh, crud. I typed in the wrong thing on my calculator. All right, so type that into your calculator or Desmos. 1 minus 4 times 7 times negative 3. That comes out to 85. All right, 85 is not something that I know the square root of. So I'm just going to go, and my choice is going to be the quadratic formula. But look, I'm practically done with the quadratic formula because I just did all that hard work there. So my quadratic formula, my answers are x equals negative b. So a negative of the b value, so negative of 1 would be negative 1, plus or minus, I just figured out the inside was 85, over 2 times a. Well, a is 7 right here, so 2 times 7 is 14. And if we look at 85, 85 does divide by 5, but that makes 17. So it's 5 and 17. 85 doesn't reduce. So I am done. Okay? All right. So let's look at letter D. I got to get this in standard form. So I'm going to pop that 13x to the other side. It becomes negative. I'm going to go ahead and add 2 to this and add 2 to that. So I get 3x squared minus 13x would be next. And then add 2 and 2, you get 4 equals 0. All right, so let's check it out. Now, if you like to figure out factoring, you could go and try and see if it factors, but this might be a little bit hard to do, so let's just see if we could. So b squared, so that would be negative 13 squared, so negative 13 times negative 13 is 169. So I'm figuring out my discriminant. Minus 4 times a is 3, and c is 4. All right, so 169 minus 4 times 3 times 4, put that in Desmos or your calculator, and you get 121. So since my discriminant is, I know the square root of 121 is 11. So you have a choice. You can either go the quadratic formula right now, or I could factor this. So I'm going to just factor it because I like to factor. All right, so 3x and x. I think I'm going to try 4 and 1 because I notice if I put a 4 here and a 1 there, I'm getting 12x and 1x. So that's 13x if they're both negative. Negative 13x if they're both negative. All right, so there we go. So my answers, I get this guy, 3x minus 1 equals 0, so my answer would be 1/3. Remember, if you need help on that, you do 3x minus 1 equal to 0, and then you solve it, add 1, divide by 3. And the other one, x minus 4 equals 0, so if I do that one, x minus 4 equals 0, I solve that, I get x equals 4. So there's my 2 answers. Okay, all right, last one down here. Let's go ahead and, so my choice here, I did factoring, but again, you could have done the quadratic formula. All right, this guy here, standard form, take away 5 from both sides. Let's see, x squared minus 5x plus 1 equals 0. All right, so I really don't have to check out my discriminant because I already see that I can't factor this. Nothing that makes 1 also makes 5. But why don't we just figure out our discriminant anyway, and then I'll just be partway done for my quadratic formula. So my b value is -5, so -5, if I square it, it gets 25, minus 4 times a is 1 in this problem, and c is 1. So I'm going to get 25 minus 4 basically, so 21. That's why I wasn't able to factor it, because this is not a perfect square. So I have to do the quadratic formula. Okay, all right, but we're practically done. So x equals big fraction. Remember out front here, I need to do negative b right there. So negative of -5 would be +5, plus or minus square root. I already know it's 21 inside there. And the bottom is 2 times the a value, which is 1, so 2. And there's my answers. And again, if any of those square roots would have needed reducing, I would have done that. Okay. All right. So your job is to do these 6 problems on this page. You're going to tell me your method. You're going to show me your work. All right. You're not going to go to photomath and like copy some crazy stuff down. All right. You're going to do what we just did on the last page. Okay. And, figure out the discriminant. Maybe, pick through the ones and find the ones that do square root first. And then the other 2, solving by quadratic formula and solving by factoring, those are kind of similar, but you figure out your discriminant first. All right. And that's it. I think there's probably 2 of each kind on here, kind of like the last page. But I'll see you in class. Have a good weekend and happy holidays.